Great to be here. I went here undergraduate. There's always something magical about coming back to your undergrad institution, which is fun. 75 to 79. Embarrassing to say. Cool. And so we have a big team at Penn and across the country and the world of political scientists like Phil Tetlock, psychologists like Barb Mellers, data scientists like me, and lots of other people, on my PhD student Vila, we'll talk about who will do this stuff at the end, trying to understand everything we can about how to make better forecasts, not so much quantitative statistical things, but predictions. How happy will I be with this person that I hire? Will this product launch work? And in our case, mostly geopolitical forecasts. What will happen in China or Russia or Africa? I'm going to try and do... That's an interesting question. We'll talk about what we can and what we can't do. So I'm going to do 3 things today. I'm going to try and cover them all. First of all, I want to make a big plea of why you should actually forecast and track outcomes, make falsifiable forecasts. That's my biggest message. It's really simple and really stupid and widely ignored across both the commercial and the industrial world. Secondly, I want to talk about what we've learned about how to select, train, and organize forecasters. We put together thousands of people making hundreds of forecasts. We have millions of forecasts collected. We've done a lot of experiments. I'm going to try and summarize them, in this case, in about 15 minutes. And then I'm going to sneak in a little tiny bit of statistics just for fun, but it won't be too much statistics of sort of the algorithmic side of putting these together, just because I can't resist, because I'm a computer scientist by training, only recently a psychologist.
So how many of your students go on to work for the CIA?
A couple. This is all funded by the IARPA, CIA, so yeah, we've done things. So research shows that people often make bad predictions. Psychology is full of people forgetting that predictions regress to the mean. People are really bad at taking lots of information and combining it. Computers are much better. Often intuitive feelings. You would interview someone, you really understand their great, how good they are, but that's an illusion mostly. Modern interviews are structured. How well do you do that? But we can do better. Now, it is the case that you're always going to be uncertain, knowing what was going to happen with Putin, knowing what's going to the Arab Spring. There are lots of things you're going to get wrong. But we've gotten better at doing it. So I'm not going to promise doing well. All I want to say is if you look at enough people and think about it, you can learn to do a better job. And I'm going to try and be a little more precise about what that means. So historically, particularly in the intelligence agencies that fund this, but in most companies in general in life, forecasts are often of the form, there's a reasonable chance that, a good chance that Hillary will win. That's nice, but that's not the sort of forecast I want. What happens is when people say words like real possibility or distinct possibility, when you go back and ask them on a scale of 0 chance to 100%, what did you mean? You get a frighteningly wide range of what does possibility or impossibility or sure thing mean? These are actually real data. If you look at this sort of in a more general thing across fields, what's the probability of election outcome? If you're a journalist, you know, it's too close to call. If you're a weather forecast, probability of rain, 50%. In Philadelphia, it's going to snow. Hey, might snow next week, going to snow. Investment, the probability of destroying the economy, 0 risk. High risk, no one could have foreseen, right? There's a lot of reasons to shade your predictions in terms of where they're going to go and to not give actual numbers that could be falsified. In particular, pundits, people who are professional at going on television and talking about these things, are really good at using words like could and might and possibly. There's a risk that recovery in the Eurozone could stall and demand might weaken so that deflation would be a real possibility. What does this tell you? Nothing. Nothing, nothing, nothing. Okay? But it's a nice equilibrium. The pundits don't have to admit that they're errors, and the policymakers aren't constrained by nasty facts. This is very comfy. And to their credit, the intelligence agencies are saying, can we change that? Can we actually change the culture and actually make falsifiable predictions? So, I probably don't need to remind people that lots of bad decisions happen. And these are quotes from major US policy makers. There's a serious possibility, there's a fair chance of success of the Bay of Pigs. First, what does a fair chance mean? A little unclear. Easy to evade pieces there. Statements of mass destruction. I don't say that the government should have known whether Iraq had or didn't have weapons of mass destruction, but we judge that Iraq has continuous probability 1. Is that really what you believe? I'm very skeptical about probability 1s. Yes, they do be the judge. And what's the chance of it being wrong? 0. They judge it has it. That's a nice weasel word, but again, it's not my kind of a forecast. If you can be vague, you can't learn. And one of the things I'm most interested in is in people getting better. How can we train our analysts ourselves to be better? To do that, you need to make quantitative predictions, not vague qualitative ones. Get feedback where you right or wrong, which means actually writing it down. Learn, you need to keep score. And that's really what we did. And I think probably in Silicon Valley, I don't need to argue this. There's a culture. I worked at Google, places that at least for serving ads, it really does keep score. But measurement is important. You want to change things, you want to learn, you want progress, you need to measure it. So how do we measure it? Yes?
Gates learned that within the last year. So how many decades was he just fumbling around without measuring things?
Microsoft is actually very good at measuring small things. Does putting a little gold box help over a silver box? They're awesomely good. They do thousands of randomized trials. But the hard part is keeping score and measuring things that are much vaguer and much general. The product launch, the move toward Xbox, the phone. So the tiny things, Microsoft has always been, at least from my memory, extremely good. But the big things that matter, that's a feeling. And again, it's hard to know. So I'm going to show a bunch of measurements of score, which is the Breyer score. The details aren't important, but I'm going to ask people for probabilities, a number between 0 and 1, and we're going to score how close it is to correct. If you say yes, if you say 90% and it's yes, then you're going to get an error of 1 minus the 0.9 you said would happen, and 0 minus the 0.1 you said it wouldn't happen squared. 1 has happened, 0 didn't happen. You get an error of 0.02, you did really well. And if you say 50-50, you'll get a 50%. The details don't matter. It's a squared error loss. Yeah?
So those of us who've gone to college generally have calculus. So in the case of, for instance, your day 4 forecast, when a day progresses and the day 4 forecast becomes a day 3 forecast, are you assuming a recomputation? Or
we ask people every day, what's the probability of the current ruler of Ghana being in power on January 1st of next year? And we take a probability every day. It doesn't change every day, but they can change whatever they want. And at the end of the time, we then sum up their score. If they were perfectly correct every time, they've got a 0. If they were dead wrong every time, actually they have a 2. So this is a scoring that says that if you were omniscient, you'd get 0 error. If you flip coins randomly every time, you get a 0.5. And if you're just pessimally, if you're so clever to be wrong every time, you get a 2. But we ask them every day, how is this doing? What's going to happen? What's going to happen? What's going to happen? Score them. Again, the details don't matter. Technically, any proper scoring rule will do, but this is a good one, widely used. So what do? We ran 4 successive years of tournaments funded by IARPA. This is the funding agency of the intelligence agencies who are interested in predicting geopolitical events. By our mandate, we're looking only at non-US questions, and questions were always formed of something. Here's examples. Which countries will officially announce they will join the Asian Infrastructure Investment Bank? And they were formed mostly in dichotomous, will this country join or not? Sometimes in multi-outcomes. I've asked when will Nicholas vacate the office of President of Venezuela, but in fact the question was, by X date, what's the probability he will have vacated? Again, very precise questions. It turns out it's unbelievably hard to ask quite precise questions. We had political scientists working like lawyers here, trying to formulate exactly, not will they be reelected, but will they be in power? which is not the same in much of the world. What does it mean to be in power? What definition of that? What does it mean to, it's all well to say, will they launch a ground offensive? Again, that's slightly vague. What do I mean by a ground offensive? So very precisely defined questions. One of my collaborators, Phil Tetlock, likes to call clairvoyant questions. One that you could actually, if you knew it, would have a clear answer, yes or no. And that's, I think, a big piece and really hard. Cool, so here's typical tracking across the time as years. This is running from December 2011 into January 2012. And we have predictions, will Putin be inaugurated as president of Russia in 2012? Says your Putin question. And we can see tracking across here a bunch of different groups. And I'll talk later about, we tried doing teams, individuals, we tried different training of different kinds. What helps? What people are good at it, what people are bad. Note there's predictions every day. Some of the groups, the prediction market here is going fairly down, so it's probably not happening. The 3-team median is doing better, and all combinations of teams is doing quite well. On average, the wisdom of crowds is helping. You with me? And the question is, prediction markets, sounds pretty cool. Other ways to do it, what works, how to train them.
So was there training going on during this curve?
No. So what we did, amazingly, at the beginning of each year, everybody got somewhere between 1 hour and at most 2 hours of online training. The forecasters are all over the world. This is an online training course. Now, one question you could ask is, will an hour of training change people's accuracy a year later? It's well known that a year of statistics doesn't improve people's probability estimates particularly well. They still think 90% confidence intervals are 50. Will working in teams help or hurt? Groupthink or sharing of information?
Depends on the team.
Were these teams in the field of political science?
The people, good point. So people were all at least a bachelor's degree. Some were political scientists. Some were students in analyst schools. A lot were computer scientists. Some were hedge fund managers. All over the map. And we have a crap load of information about them, which I'll talk about later. Yeah.
Did they know, was there a prize at the end that they would be personally identified with if they were really good?
There was a leaderboard. For each treatment, each group, there's a list of names of the lowest Breyer score of the best people. That was it. No monetary prize. We paid them a token like $50 a year, which is way under minimum wage for what it takes to actually run these things. But, people are into it. And all you got out at the end was your name on a list of how well you did. Good questions. Okay, so we beat taking a random set of people and averaging them by 50 to 70% on the Breyer score, the error. We got a big improvement. We were enough better than the other teams that IARPA canceled most of the other teams and gave us a bunch of the money and took them on as collaborators. It was really nice. It boomed away. And I think we learned 4 things. Get the right people, which I'll talk about. And we took the top couple percent and called them super forecasters, anointed them. Exploit good interactions. Put them on teams in the right way, either on teams or prediction markets, and I'll talk about the relative benefits of those two today. Teach them, amazingly, actually an hour of online teaching changed forecasts throughout a year, which I find staggering. I was on the other side of that bet, but I learned something. I was wrong. That's good. And develop good algorithms to integrate and combine these forecasts. It turns out that averaging probability estimates is really stupid, and even averaging real numbers is mostly stupid too, for reasons I'll get to. Cool. So the first question is, are there really great people? This is not an earthquake. I go to the East Coast. I always think this is what California looks like, the seismograph. But these are the questions closing from the 26th to 199th. We took the best 100 people and looked at their average score, and the worst 100 people, remember, higher is worse, Breyer scores. And on average, the worst 100 of the first 25 questions are pretty reliably worse in the future. People who are bad in the past are bad in the future. Okay, that's encouraging. There's some signal there. They get some right, some wrong, but it helps. So we want people who are good. Who do we want? Fluid intelligence, Raven's test, IQ helps. Political knowledge, less so actually. Somewhat surprisingly, perhaps, the computer scientists were just as good at forecasting as the political scientists. Being experts on things didn't help. Now, maybe it's because our range of problems was huge. It was everywhere in the world except the US. It included economics and politics, military, civil unrest, lots of things. Maybe nobody knows all those things. But for whatever reason, it turned out that having a professorship of political science at a good school was not vastly helpful.
I would say that's very interesting because I've seen quite a few publications that found the opposite. Found that people are much better in their domain area.
And I think one question is, what's your domain area? Are you as knowledgeable about what's happening in Ghana as you are happening with the economics of the EC? Are you as good at forecasting oil prices as you are about? So nobody in our area knew all the stuff. If you're going to do well, you had to go out there and go to the web, find things, read stuff, figure it out. And I think it's not contradicting the idea of subject matter experts, but it's noting that if there's a broad enough set of questions, maybe that particular expertise doesn't help. Yeah?
Does fluid intelligence just mean able to change their mind?
No, fluid intelligence, in IQ tests, there are two things. There's fluid intelligence, which is sheer horsepower, how smart you are, and crystallized intelligence, how much do you know? So these are psychology terms. So fluid intelligence, measured by the Ravens test in this case, is those little diagrams with the circles and the little lines in them that just check pure IQ as opposed to knowledge, well, piece of IQ. More actively open-minded cognitive styles, people who thought more, thought longer, were more flexible in their thinking, and we have, again, questions for measuring these. Greater need for cognition. People wanted to complete, figure it out, don't take the final, first answer is the final answer. People who measured things in tenths or 0.05 in probability, when people said 0.25, 0.5, 0.75. We can see how accurate someone was if they're saying 25%, 50% as opposed to 30%. The 30%, 35%, 33% guy or woman, better. I'll talk about Fermiizing, breaking problems into lots of little pieces, decompose it. We'll talk more about that later, how to do that. People believe that you actually, the world was deterministic, you could understand it, you could figure it out. They don't believe in fate. They believe you can figure things out. And belief that you actually can learn stuff. It's sort of funny, self-fulfilling cycle, right? I gotta come out like Carol Dweck stuff here at Stanford. Growth mindset, if you haven't seen it. Meet Carol, she's good. Okay, so find good people, smart ones who want to think about things and figure them out. Teams versus non-teams. We tried prediction markets. Here's sort of a classic, how much you bet on this last year's Obama. McCain, remember him? Or more modernly, here's today's version of the Democrat winner-take-all versus Republicans. Looking better. So prediction markets, you get $1 if the Democrats win the popular election. Why I care about that, I don't know. Versus what is much less done is prediction polls. And I don't mean opinion polls, not who will you vote for, but who do you think will win? If you go and take a random set of people of our piece and say, who will you vote for? That's not very helpful. It's a very biased sample. Not a lot of Trump supporters out there. You ask, who do you think will win? You learn something much better. Make sense? And we'll talk a little bit more about when you might want to do each of these, but they're both different ways of getting wisdom of crowd, lots of opinions. The other question was, should people be put on teams or not? And most people I asked said, no, teams lead to groupthink. You get too much reinforcement of stuff. Here's what we found. Here's the prediction market earnings, how much money they made. More dollars is good. Individuals, teams, and the super teams are the best 2%. Here's Breyer score, smaller is better. This is accuracy, squared error loss. Independent predictors, teams, super teams. Teams are a lot better than individuals. Now, we know that teams often lead to groupthink. What's different here? First of all, our teams are not sitting around a smoke-filled room with a guy with a tie or someone with short or long hair. Our teams are all internet. This is all distributed. There is no obvious social hierarchy. It's got a very different structure than many of the old-fashioned team studies. And I think there's some evidence.
How are they combining their knowledge?
They have basically a structured platform for sharing information. What we have is a way for them to text each other, put comments on theirs. We tell them, you're on a team. You guys are individual. I'll just rank your names. You're on a team. You'll each make your own predictions, but the leaderboard will have your team name. We'll never show where your name shows up. Your goal is to make your team have the most accurate predictions. If you two disagree, you may each put your conflicting probabilities in. It's okay with me. We'll average them. But the team at the end is what matters. And the team say, hey, here's what I think. No, that will never work. I know the EC, they're way slower than that. That's ridiculous.
So you average the probabilities.
So it's the average of the
You
probability.
look at distributions and
Yeah,
max likelihood.
we can do fancier other ones, but the team in the end is the average of the scores of the people on the team. Right? Everybody gets their prior scores. We actually we average the prior scores. We average your score, your team score is the average of the people on it. If you can get his score up by saying, no, you're crazy. That's not really what's happening in Russia. They're just saying that, but that's cheap talk, or not. If you can convince him, you can raise the team score. Okay, so there's an incentive based only on leaderboard to convince the other people on your team, and they share each other's predictions and the reasons behind it. And we have all this communication, it's all electronic, so you can analyze it. That's another talk. Make sense? So these sort of teams turn out to be wonderfully good, much better. And there's this super additive effect that once you put together smart people who are engaged on the same team, then they just, boom. They get really excited, they get really engaged, they really do well. Much better than they did even, and these are often multi-year ones, even they did before as individuals. Yep.
Speaking of money, I presume you're going to talk about stock market, or is that the last?
I'm not going to talk about stock markets. These are prediction markets. There's no real money here. I guess, no, this is all fake money. This is all fake money in our prediction markets. Everybody gets their $50 a year, and you get a list on the prediction market of how much money you made. No real money. You can argue that real markets are going to be efficient and better. That's an interesting question, but I'm interested in many cases where you're inside the intelligence agency, you're inside your company, you don't want to run a real money market. What you want to do is aggregate the opinions of your experts into an overall piece there. Most companies don't want to run prediction markets with real money internally. Lots of them, from Ford to Google, have run fake money prediction markets, but it's not really common to run real money ones.
So your teams here are not only putting a probability out there, the average, they're putting a bet out there as well.
They're putting
A bet?
well, yes, every probability is a bet.
Yeah, but they're also putting a certain wage, they're choosing.
No, the prediction market condition, they actually put dollars. How much will you pay for this outcome? In the prediction poll, they're just giving a number between 0 and 1, each person. So they're quite different. We also ask them how confident you are, but they're not rewarded on that. That's just another piece of information for us to take for our algorithms.
And when team members disagree about how much wager to put on it, you average, or each?
They all argue, and in the end, each of them has their chunk of funny money. Each person puts whatever he or she thinks they believe. You can fight against each other on that.
Okay.
Make sense?
So,
Yeah.
trying to figure out the gaming that went on, because you said you had hedge fund people. If John and I are in it, and I'm convinced he's wrong, can I help my team by overestimating? And I know which way he's going to be wrong.
Potentially you could.
Can I help my team score by, instead, I think it's really 80, but I think he's going to go 60.
In the prediction market, you can. The prediction poll, you can't. Interesting thing is that some people like the prediction market because it's fun and gamified. More people dislike it, because at least among our people who are participants into this, who are into politics, I don't want to think about gaming the system. All I want to do is understand what's happening in the Congo and give my probability and talk to my people. So we had more people who dislike the prediction market and don't like having to think about what these ramifications are.
Correlation. Being good in the game doesn't necessarily make you a good expert, and vice versa.
Correctly so. And so,
Inverse.
yeah, so it does turn out that people who are better in the prediction market are better predictors, but not as reliably as pure polls. So one thing I argue is that this gamification has maybe gone out of control in some of these prediction market settings, at least for these sort of cases with intrinsic interest. Just let people make the predictions, do the leaderboards, see how they do. Cool. Training. Amazingly, training worked. If you want, you can go into training.goodjudgment.com and take the training where we've done these. I'm going to walk really quickly through an hour-long training in about 4 minutes. First thing is really obvious after you think about it. Some things are more predictable, and you can figure out. Some things are less predictable, just purely random noise. You want to think about the things that are sort of in the middle, where it's neither blazingly obvious what the answer is, nor impossibly hard. Don't waste your time if you're not having a chance of figuring something out.
You did read View by didn't you?
I did not.
You might put the roulette wheel further to the left.
Ah, yes, oh yeah, that one I know. Yep, okay, that one's fine. It's still, yes, a little to the left. That one I do know, the piece there, yeah. I went to MIT. Biggest one in terms of methodology, reference classes. Ask a question, will this dictator who has been in power for 20 years remain in power for 1 year? It's nice to say I'm Bayesian. Compare to comparable people. What's comparable? What's the right thing? Is it all African dictators? Dictators who've been in power for 5 years somewhere? Outside of Africa or not? 10 years, 20 years? Maybe the health matters. What's the right group to compare against? And that actually takes a lot of thinking. And I'm an AI guy. I like all these deep networks outside. Really hard to automate this sort of forecasting of finding what the right reference class is to compare against. The right balance between inside and outside view. You ask most people, will these couple be married in 5 years? Let's try and do a precise thing rather than happy. Most people look at that sort of thing, think how happy they feel, and translate that to a probability. That's a really bad way to go about making forecasts. Much better is to start with some statistics. We know what fraction of first marriages, second marriages, third marriages end in divorce after a certain amount of time. Start with the base rate for the right comparison class, then adjust it based on what you know about the person. Hugely useful piece, and something you can teach someone, and after a year, if they practice it every week with real feedback, why did the training work? I think because they're getting feedback. They're using it every time. You figure out, did I do the right thing or not?
So you just adjusted your prediction. You said,
Yep.
I was right all along, you just needed a bit more information. So you said the training class didn't work, but it worked because you did this other thing instead. So you fixed your initial prediction. You changed the world.
Yep.
Okay. So you were never wrong.
I was wrong, and then I changed and learned. Try and be as fine-grained and precise as you can. Try not to say maybe or unlikely, but try and give an actual number.
You're missing on definite maybe.
Yeah, I'm missing all sorts of things there. Break things up into pieces. Classic thing from physicist Fermi. How many piano tuners are there in Chicago? How many people? How many households? How many pianos? How long does it take? Figure out the number. I worked at a Boston Consulting Group. This was a classic sort of game you would play on the interview circuit. Break things up into pieces. You can answer lots of specific pieces about it and multiply them back up again. So decomposing problems. And finally, postmortems. This is what happened. Why did I get it right? Why did I get it wrong? Try to learn from it. And these are particularly useful and helpful on the teams, where you get the teams coming together and saying, crap, we should have got that. Or we got it right, did we get lucky? Or was it because we were skillful? Again, this learning and self-feedback piece. This is my one really messy slide, but I gotta show you a formal mediation model to show how much these things with little numbers on them. So Breyer score, down here, the answer, smaller is better. Actively open-minded thinking, slightly lowers the people Breyer score. Training, bigger effect. Teams, bigger effect, and teams also affects positively the time spent viewing questions. So teams both directly make you better and they make you spend more time looking at stuff, which makes you better. If you work harder at it, you get better results. Intelligence. Yep. These are correlation coefficients, yeah. All correlation coefficients, sorry, thank you. Political knowledge helps some. So here's a minus 1.6 lowering thing. Political knowledge also, because more political knowledge also update their bleats more often. They're more engaged. They do a better job, which makes a big effect. Raven's IQ, we did numerous cognitive reflection task, a bunch of different components of IQ. I don't want to go through details, except to note that there's this sort of key pieces of mediation. Being smart, working on teams, political knowledge, both make you more involved, update more often, spend more time, and even above and beyond that, make you better. So that's a lot of slides there, but that's it. Cool. Fourth driver, and final one, extremizing algorithms. It turns out that averaging probabilities is a really crappy thing to do. First of all, they're not Gaussian. And I'm going to talk a little bit more about how to combine pieces there. But we do surveys of individuals. The teams are better. The supers are better. If we do the right statistical hocus pocus, which I'll talk about in a second, the individuals who are really crappy, the wisdom of the crowd comes out. They do a lot better, almost as good as the supers. We get sort of somewhat similar effects in prediction markets. But the extremizing there doesn't help as much. So what am I saying is that if you have a bunch of crappy forecasters, if you combine them in the right way, which is not averaging them, you can do almost as well as having the top 2% working in really good teams. Not quite, but close.
So that basically is a team that has no communication between team members.
Right.
Okay.
Exactly. So a team, a group that has no communication helps. Don't get me wrong, it's reliably across all 4 years we get better for the teams. But you can do something that's somewhat close to it by actually doing a good combination. And it turns out, somewhat surprisingly or not, I'm not sure, averaging is a horrible thing to do, not only for probabilities, but also for real valued forecasts. And I was taught sort of all of statistics is averaging stuff, but we'll come to the sort of technical part of the talk and show that that's not the case and give some intuition.
Involved in that, in your blue ins?
Yep.
Similar to the size of the teams, or is it like a lot more people in that part?
Same number. So we control, all these are controlled for number of people. Yeah, absolutely. So all of the supers are selected out as better people. Everything else is random assignments, equal numbers of people, controlled for everything we could. So what happens, and these are part of the labels, I'll explain in a second. This is looking at how much better or worse, in this case, higher is worse, different groups do compared to the prediction market. If you just take an average of individuals or average of people on teams, you're 20 to 40% worse than the prediction market. Prediction markets are really good compared to just averaging people. They seem to have a certain magic there. Well, first thing you got to do is not average everybody's forecast throughout the whole thing, but decay, throw out more of the older forecasts. And now the prediction markets are still, prediction market uses a close every day. We're valued at the end of the day. What's your prediction? It's still the case that it's 10 to 20, 10% for teams, 20% worse to average probabilities of a group than do a prediction market. So prediction market is still good compared to averaging. Now we can weight people based on how certain they are and their history of performance. And now we're pretty much matching. We can't distinguish ourselves from the prediction markets. If we do clever transformations of the team's average by moving them more extreme. If the team says 0.7, we should say 0.8. If they say 0.85, we say 0.9. Extremizing the probabilities. At that point, we're statistically significantly beating the prediction markets.
What about the inverse, kicking out outliers?
Well, that is a version of kicking outliers. So you can take the median.
Not kicking out by
Yeah.
biasing it?
It turns out that just taking the median, which throws the outliers, much better than the mean, but still not nearly as good as an intelligent combination.
The ends mean whatever.
So
this result again is exactly opposite of what I would
Okay.
imagine, because in
good.
cognitive bias work we learned that people always are too overconfident, and we get probabilities that are
Yes, so note there's an interesting contradiction here. Individuals tend to be too overconfident. However, averaging a bunch of people gives even if they're all each individually overconfident, gives a combination that is underconfident. Okay, and I will try and explain that apparent paradox to you. That's my last 20 minutes. Yep.
Somewhat related to that, it seems almost counter to your earlier note that people seem to predict better when they are more granular, which seems a little bit counter to then extremizing all of that.
Now, granular is how precise. It's a measure including of how hard you think. It's, I think, entirely separate from this notion that says that even though individuals are often overconfident, although our super forecasters are remarkably well calibrated, normal people and often things are often overconfident. It's still the case that when you average people that you wanted to take into account some information overlap. And I'm going to come to that last, perhaps non-obvious piece.
You have an individual one, like a dotted one,
Right.
Which it sounds like extremizing is still helping.
No, this is not the extremizing of, not for an individual, not extremizing your score. I take 30 individuals, if I average them and then extremize, I do better. So the individuals are a set. Picture 30 individuals combined together versus 30 people on a team. But it's still combining 30 individual forecasts, which is not the same degree of overconfidence, miscalibration of each of the individuals. You might think you take a bunch of overconfident people and average them, you would get something that's overconfident. It doesn't follow.
It almost sounds like a converse, that you're using one metric individually and then the inverse metric for the averaging across the group.
Yeah, so in general, for individuals, you want to take their forecasts and shrink them a little bit back toward the mean. So if you have individuals who are here, out here, you want to pull them in. If you have average of individuals, you want to pull them away from it, make them bigger. It's sort of backwards. So let me try and talk about that with my last third, about the idea of information diversity. Now, there's a large literature that argues that more diverse teams are better. We tried slicing and dicing our people in a million ways, male and female, political scientists and computer scientists. No benefit. That sort of diversity didn't help us. Now, arguably our people are not diverse enough, but there were men and women, young and old, PhDs and bachelors. None of that sort of diversity helped or made any difference in our statistics. Our people all look sort of the same. Okay, maybe that's the volunteers we have. I'm not saying it's a true. So that's it. They're all people who are geeks interested in political science forecasting. But we did find that there are correlation structures over people. People tend to systematically agree or disagree with people. And that's something we can use to do a better job, have people make a whole bunch of forecasts. And interestingly, even if I don't know the truth, each of you makes a bunch of forecasts. You guys always agree. You tend to disagree more. When I combine them, I want to downweight the two guys who are always agreeing. Don't count them twice. They're probably both reading the New York Times. That's great, but I only want the New York Times once. You're saying something different. Could be because you're stupid. Could be because you're smart. I don't know. But it's a good thing to do statistically, in my experience, our group, to give you a little bit more weight. And that is this notion of information diversity. If you think, there's a 5% chance of this guy dying of a heart attack next year, and there's a 5% chance of a coup, the thing to do is not average the two 5%. The chance of him being out of power, roughly 5% plus 5%, or maybe minus the product of those, which is basically 0, it's closer to 10%. You with me? So this notion that if people have different information, it should push things more extreme is the key to this information diversity. And we tried to see if we could track what people were reading, and we asked them questions, are they boomsters or doomsters or left or right? I never could find a systematic, Phil believes in realpolitik versus, we could never find a good question to measure this conceptual diversity. But we had a lot of answers. I'm a statistician. I can just measure the diversity together. So what I want to argue is that the statistics that I was taught when I was an undergrad at Stanford, and which I still teach at Penn, says the way you estimate things is there's truth plus noise. You make a bunch of measurements, you average them, and you average out the noise. And that's great.
You do communication theory of bits.
Yes.
Your curve.
That's right. And this is an interesting thing which says that if you're measuring something repeatedly with noise, averaging is the right thing to do. But that's not Gaussian linear. But that's not the model I sit in. The world I sit in, there are people, each of whom read different newspapers. Some read Russian, some don't. Some put more credence in a realpolitik. Other ones actually believe what politicians say more. Each expert sees overlapping chunks of information. They read some of the same. Everyone in our group reads the New York Times, but the Post. They read different things too. They have different things they take at it. And they use that information to make forecasts, and I can see who's correlating with who and use that to reweight it. It's a little more work mathematically, but it works quite better. Here's the math slide, which for those who are math geeks, the rest cannot worry too much. I get a set of estimates from my forecasters. I'm going to find the covariance between them, how much they tend to agree or disagree. I'll show you a picture in a second what that looks like. And then, well, for real valued estimates, if you assume some simple Gaussian model, unbiased, you get an estimate that looks roughly like the inverse covariance matrix times observations with a little other pieces there. What do these covariance matrices look like? Here are our 5 most active forecasters, and you can see that some of them are highly correlated. These super forecasters A and B are really close to each other, but not as highly correlated with super forecaster C. These individual A and B, much less forecasting. So you can see actually which people tend to agree with each other, darker color, which one tend to disagree more. With me? That is the covariance matrix. Here's our covariance matrix, 100 forecasters, a larger set. And you can see again, there are sets of them that tend to agree a lot. In particular, super forecasters working on teams, share information, do things they tend to agree a lot. The teams in red agree somewhat less. The people working in isolation individually tend to agree even less. So the correlation, not surprising. If I'm on a team with you, we tend to make more highly correlated forecasts. Oh, and we should downweight each of ourselves a little so as not to double count. But we're not perfectly correlated.
Yeah, your diagonal there also showing the variance, which shows that your super forecaster A tends to make more extreme predictions. Is that a correct interpretation?
Yeah.
Variance is going to be close.
Yeah, so you get a variance. So the model has sort of 2 pieces, which makes it, one is the covariance, the other is some estimate of what fraction of the total information someone sees. So we have overlapping chunks of information, and people vary in whether they see a tiny bit of information or a lot of it. And the super forecasters are closer to seeing more of the information. And if you have more information, this all assumes people are rational with some sort of Gaussian noise. If you have more information, you should be making more extreme. If you're ignorant, you should say 0.5. The more you know, the closer you get to 0 or 1. Averaging the 0.5, and it's funny, 0.5 means a couple different things. 0.5 either means I'm really knowledgeable and it's 50-50, or it means I'm clueless. Averaging the 0.5 clueless guy and the 0.9 I'm pretty sure guy, bad idea. The 0.95 guy just said I'm clueless, right? I'm uninformed. And that's, again, why you don't want to move it. If you average 0.5 and 0.9, push it away. Make sense?
Actually,
Yeah.
inverse X matrix is decorrelating the different sources.
Exactly. So decorrelating different sources, and you need to have this be a covariance matrix. It has to be positive semi-definite, and there's some pieces for estimating, which I don't want to talk about, but except that it requires a little bit of tricky math because that matrix does need to be positive semi-definite. So for the math geeks, there's a little technical detail to make it work out right. The problem is the empirical estimates aren't. If you just throw the correlations in there, you get all sorts of crap. So you've got to do some clever things to make sure you actually get a sensible matrix out. The empirical estimate is not a good one, but that's way too technical. So let's do it easily with dumb things. A colleague of mine, Don Moore, went around the Berkeley campus with a scale and a camera, took photos of a bunch of people, and weighed them. He's got a bunch of people. Here's some real participants, and know how much they weigh. So far, so good. Now we'll ask a bunch of other people, Berkeley students, how much does each person weigh? Now you might think, I would have thought a year ago, 2 years ago, that the thing to do if you ask 20 Berkeley students the weight would be to, say, average them. Right? I got 20 estimates of their weight, take the average. That's a good wisdoms of crowd thing. It's not bad, but here are 20 different photographed people and weights. The red is the true weight of the person. And you see the histograms. And what you can see is that on average, the median rater of all these raters is underestimating the weight of the heavy people and overestimating the weight of the light people. You with me? The average, or the median even in this case, the median, it's better than the average, but the median estimate is shrunk toward the mean, even though I don't know the mean. You with me? So something funky is happening. It's not the case that just taking the median estimate is good. We want to take the heavyweights median and squish it up, and the low ones and push them down. And we can use the covariance across these different raters. And this is weird. They're all seeing the same information. It's a photo. What do I think's happening? I don't know. But I think they're looking at the face, looking at the weight, looking at the male or female, looking at different features. Different people pay attention to different things. And based on that, there's some correlation structure over the ratings, the estimates of the weight. You with me? And if we do a better job, well, here is the average, as I take the number of forecasters going from 10 to 70. The average gets the error, root mean squared error, goes down. There's the median, there's the average, and black is our revealed aggregator, our statistic. With less than 20 people, you're actually better off taking the average because we can't get a good estimate of the covariance matrix. As I get more than 20 people, we get noticeably lower error than averaging the weights. The same thing happens with uglier math with probabilities. Now you need a link function. They're no longer real numbers. And you get something that's sort of fancier, but basically still has this covariance matrix in there, plus a few other crappy pieces that I want to talk about. But it's basically the same sort of thing, but uglier with probabilities. You need an inverse cumulative distribution function for the Gaussian. And what do you see? Forecasters going from 10 to 50, root mean squared error. The average goes down as you get more people, reasonable crowds. The median is much better. The average of probabilities is crappy because they're not good. A better thing is to average log odds, which are closer to Gaussian. So that's even better, or probit similar. And we're doing a lot better.
What about harmonic mean? That's Hennessy's favorite for measuring.
Yeah, we tried harmonic mean, we tried all these. It turns out that none of them are as good as actually using this covariance matrix. If people made a bunch of forecasts, even if you don't know the outcome, then using this covariance matrix helps. Good, so I need to move toward the summary piece here. 10 more minutes before I get thrown off. I want to give a little bit of perspective of what I think here. I think tournaments have maybe 3 main big uses. It's a testing ground. We can check what works, what's different about people, how are actively open-minded thinking or intelligent people or biases work. We can compare prediction markets versus surveys. For this stuff at least, if you can't do any statistics, if all you can do is average, you use a prediction market. If you can afford a day of a good statistician, the prediction polls are better. Ask people probabilities and then do a weighted combination of those. We saw some cool things in aggregating, finding diversity not based on black versus white or men versus women, but diversity based on the sheer empirical. Do we tend to mostly agree or do we disagree more? And I haven't talked about it today, but there's an interesting debate going on in the intelligence community. Mostly they reward process. Did you go through and measure the right sort of things? You consider the right checklist. Did you follow the process versus were you accurate? And we can look to see which of those lead to better outcomes. And not surprisingly, it's better to ask for outcomes. Interestingly, if you want good reports, you can do a hybrid system where say, hey, I'll give you partly a reward based on following the process, generating a good report, and partly based on accuracy. And you can sort of get the best of both worlds by combining those. They're economic functions. Firms can do a better job of predicting, which is good. And I think more interestingly, spot and cultivate people. Astoundingly, to me, again, this hour of training, and I only gave you 5 minutes, you did an hour, helped if people actually had to make predictions every week for a year. And one thing we found measuring open-mindedness, so active open-minded thinking was one of the measures that correlated. And we looked over time, number of years people spent with both surveys and prediction markets. People went up on average in their open-minded thinking as measured by our questionnaire. That getting feedback that said, hey, you missed it, duh. Oh, you got it. If you have that happen, say 100 times, people start to spend a little more time, be a little more flexible about considering alternate hypotheses as to what might happen.
Can you clarify what you mean by tournament?
Tournament, I mean either a prediction market or a prediction poll. So I'm trying to have some general notion of this, a group of people competing in some sense by making predictions. So I'm trying to group my prediction markets and prediction polls in a single competition with measured outcomes. And over again. So there were 100 questions a year. Really involved people did all 100. People often did just 30. Many people did it for 3 years. So it's 30 questions to 100 questions a year for 3 years for the modal person going through making predictions every week. And then you got it. You missed it. Yeah. And I think it's something that's widely missing in politics. And I don't mean even just in this amazing set of Republican convention discussions, but this notion of a pure accuracy, not just what should be done, but what will happen. And I think this notion of pushing for actual quantitative forecasts and accountability is at least one tiny piece of a way that might bring a little more sensibility to discourse. What do you think the chance of this happening by this date is, rather than just, yes, it will be horrible or wonderful or whatever. And maybe if we do this, we can actually get the political process to have more learning and feedback. That would be wonderful. I'm more sanguine about it happening actually in corporate America where people really do care and measure these things. Finally, this project is finished for the first phase. There's a second phase starting up, but there is now a company, which have no financial interest in, and there is a Good Judgment Open, an ongoing public platform. You can go and play yourself, make the forecasts, take the training. It's there. And if you have any more questions, I'll take a few here, but you can email me. Thank you. And no one had questions. Yes?
Did you look at the effect of time to decision on your tournament, how it impacts accuracy?
Yeah, so people who do spend longer thinking on the questions do, in fact, are more accurate. So certainly the amount of, that's your question, the amount of time spent on task correlates very highly with accuracy. People who are more engaged, who work harder, do better. Absolutely.
Through the roof. I mean,
as far as I can tell, it's pretty monotonic. I mean, again, there's a fair amount of noise, but in general, the more time people spend at it, the better they did. Yeah?
What about external factors that you have nothing obvious to do with the predictions? Huberman's worked on prediction markets where they weighted by risk tolerance. Are there other external factors, happy people versus sad people, or just crazy things that you could think of where it might correlate?
It might. We tried a bunch of those, including, political orientation and lots of things that might have made differences. And I reported all the ones we found. Lots of other things didn't appear to matter, or at least were too small to measure. But if it's too small to measure here, it's going to be a long time before someone does another million forecasts measured like that. So could matter, but I couldn't find them.
In subject selection,
Yep.
polling agencies and stuff are often reluctant to open up polls to volunteers and stuff because then you get motivational biases and stuff. But I'm wondering if your correlation adjustment might actually kind of offset that.
I think it's interesting. It'd be fun to go back. So, for example, there was a prediction market at Google where they had predictions of product launch successes. What you find is that more senior people did better than junior ones. People who were too close to the project were too optimistic. As you got a bit farther away, you got better. And so I do think that if you have that sort of information, you should be able to actually feed it in and do the reweighting And again, the problem with the prediction market, it's a black box. You can't go in and tinker. We tried a bit, but it's really hard to go in and tweak the prediction market. Whereas if I ask you probability, I can use all sorts of facts about you. Is it your project? Is it not your project? To do appropriate reweighting. And so I think I've become a huge fan of prediction polls. Ask people and learn something about them, and then use that to do the aggregation rather than to let the market do itself. These are not like financial markets where there's in theory always more money to flow in. There's a limited number of people who are going to predict your product or your outcome.
Do you have thoughts about applying an open market to like the presidential primaries and stuff? You know, where
so there are lots of prediction markets running. The Iowa markets make predictions. They have been historically fairly accurate. You can compare across different ones. You can see the variance across them as a little arbitrage possibility. So they don't do quite as well as the very clever forecasters that take the prediction markets as one of their inputs to their algorithms. But they do fairly well, actually, for the U.S. markets where there's fairly good information. The question becomes more problematic is as you go to more and more obscure countries and pieces there, how do you, or internally to companies, where you have smaller sets of people, how do you do that? And again, the prediction markets get very thin. We only have 5 or 10 people. Whereas prediction polls, you can always ask to 5 or 10 people their probabilities and aggregate them in a sensible fashion. So again, I think the prediction polling is much more flexible on this small side, which I see as more common across from intelligence agencies to companies.
Go ahead with prediction polls, open it up to the public,
Yeah.
let people do that instead of having these rating agencies and stuff that are actually feeding the press the numbers. But then you get your various biases from the public and stuff. But do you have thoughts on, is that a viable way to make things work?
I think the only thing to watch is, you want to make sure there's no vested interests in the parties in question in gaming the system. So the problem with a lot of these, if somebody wants to make their candidate look good, then they push the pieces there. So it's got to be a little bit careful that it's not structured in a way where people have some incentive to lie to you, which is often the case. So that's my one big concern these. We are going to try, I hope, to do some of these with marketing forecasting to get a bunch of people. I think we should be able to do a better job than purchasing agents at deciding what to buy for the next fashion season, but we'll see.
Yes, but in many cases, the outcome, what people are rewarded for is not prediction accuracy.
Yes, in general, people are not rewarded for prediction accuracy. That is, in fact, a huge problem.
The best person to do, say, market prediction is not the person who's best. It's the one who makes the most money from making market predictions, which is a different property.
Well, I think particularly within companies, the pundits have the idea of making a prediction that will actually get them on television, which encourages ridiculous things. And people at many companies, I remember, I won't name the company, but a major chip manufacturer not located here, if you made a high sales forecast, you could reserve more time on the manufacturing plant. And if you made a low forecast, you couldn't reserve time. And there was no cost for overestimating. Guess what all the salespeople did? That contract will be here next month. No problem. Sign me up on the machine, because if I can't make that custom chip next month, I can't get my commission. So there's a huge problem with people not being incented or being disincented. But again, that partly comes from not keeping score. These salespeople were never penalized in any fashion for being systematically optimistic on their forecasts. So yes, you need to have a reward structure that makes this actually matter, and that means a cultural change. Yeah.
In adaptive control, they figured out you basically have to decorrelate that process too, so that they divide the data up in 3 parts. And the ultimate test is on the 3rd part, so you can't cheat basically. Not even a smart algorithm can cheat.
Yes.
Can cheat.
Yeah. Yeah, and these are.
You should be able to do that too.
Note that all these forecasts, except for the pictures of the thinner and heavier people, were predictions about the future, about unknown events. There was no way to cheat because nobody actually knew the future. And so I do think that having this, make the forecast, write it down, have it something, have a systematic, go back and look at it, that's really basic.
In 2 years.
Yeah.
If you're in the right organization.
So here's the thing, I don't have a security clearance, but I'm told by leaked information published in the Washington Post that we are more accurate on the exact same questions that the internal prediction market of the security agencies did. So that people having confidential information were less accurate on average than our people.
Ability to put your thumb on the scale.
If you can actually take an action, right. So all these are subject to something. Sure, if you can actually affect it, if you have your finger on the trigger, you could literally, then you can change things. Absolutely. And that's another question of incentive compatibility. Our forecasters, none of our forecasters were in a position to actually pull triggers, I hope.
So when you use the correlation adjustment
Yeah.
method, if I was doing a study with a bunch of experts and I gave them a bunch of questions, would I be able to take the correlations on those questions and then readjust the same questions, or would
Yes.
I be completely screwing up the statistics?
No, you can take, because what you're doing is you're taking their predictions, not looking at the outcome at all. You're taking their predictions, finding the covariance, the correlation structure of the predictions. That's the only thing. That's my sigma, that's my covariance, that was those blocks. Take that, basically invert it, and then rescale it on the diagonal with a little piece there, and then use that to combine their predictions on the exact same data set, but now you're looking at the predictions. So yeah, it sounds almost circular. It does require people, you have to make very strong math assumptions, only take one prediction, which we're working on, but it works best if you have a bunch of predictions by the same people. Now, many of these are only partially overlapping, because of our 100 questions, a lot of people did a different 30, but there's enough overlap to estimate that matrix, and then basically invert it to do the weighting.
And what would be the publication to look for this method, or the site? Would it be an article by you, or is it?
So we have a bunch of these in this political science. So I guess there's two sets of them. In fact, there's three. Phil Tetlock has a book, if you want the qualitative one. There's a book which, if you look at Tetlock, has the big picture political science one. Bart Miller's and a bunch of us, including me, have a psych science one on psychology, and Vila and I have a bunch of statistics ones. The simplest thing to do is to email me. I'm Ungar, UNGAR, at Penn, and and with whatever question, I'll point you to which of the literatures are very different in style. The book is quite popular, Phil's book, really readable. Vila's stuff is stuff that you would like because it's real mathematics in it. So these are in JASA and real statistics journals. So we're all over the map.
Yeah, Tetlock, I think, gave a long now lecture just a few months back in the Bay Area. And he had about 500 people in the audience.
Yeah, he's been doing a bunch of stuff on these things, and he gives a great talk. But there's no math in it, so mine is more fun.
In the last election, I followed the prediction market on Politico. I think they were pretty good.
Yeah.
You can comment on that, but I'm more interested in which prediction markets would you recommend to watch for this election round?
There is actually a site odds tracker that goes, most of the prediction markets are outside the US because the US government really strongly regulates who can run a prediction market because it's viewed as gambling. So most prediction markets are outside. There is a site odds tracker that has 5 or 7 different prediction markets. You can look and see the agreement between them. But they're all pretty efficient in the sense they tend to agree with each other.
Generally, you're saying outside the US, it's less biased.
No, it's less regulated, so it's easier to start one. You cannot go off and start a prediction market without.
The regulation puts in bias then? Is that what you're saying?
No, it just makes it harder to. It limits the number of prediction markets.
There are multiple prediction markets that don't agree. Doesn't that open up arbitrage?
It does. And the interesting thing is that although in theory you could arbitrage, there's just not enough money. Most of them have very tight caps on how much money you can put in, especially within the US ones. And so there's arbitrage opportunity, but it's not very big. And it's not a good way to make a living if you.
You have to decorrelate.
Yeah.
You have to decorrelate the market.
Yeah. Great, thank you. I'll hang out for questions. You were wonderful. Worked at Google, places that least for serving ads, it really does keep score. But measurement is important. You want to change things, you want to learn, you want progress, you need to measure it. So how do we measure it? Yes?
Gates learned that within the last year. So how many decades was he just fumbling around without measuring things? Excuse me.
Microsoft is actually very good at measuring small things. Does put in a little gold box help over silver box. They're awesomely good. They do thousands of randomized trials. But the hard part is keeping score and measuring things that are much vaguer and much general. The product launch, the move toward Xbox, the phone. So the tiny things Microsoft has always been, at least from my memory, extremely good. But the big things that matter, that's a feeling. And again, it's hard to know. So I'm going to show a bunch of measurements of score, which is the Breyer score. The details aren't important, but I'm going to ask people for probabilities, a number between 0 and 1, and we're going to score how close it is to correct. If you say yes, if you say 90% and it's yes, then you're going to get an error of 1 minus the 0.9 you said would happen, and 0 minus the 0.1 you said it wouldn't happen squared. 1 has happened, 0 didn't happen. You get an error of 0.02, did really well. And if you say 50-50, you'll get a 50%. The details don't matter. It's a squared error loss. Yeah.
So those of us who've gone to college and in calculus, so in the case of, for instance, your day 4 forecast, when a day progresses and the day 4 forecast becomes a day 3 forecast, are you assuming a recomputation? Or
we ask people every day, what's the probability of the current ruler of Ghana being in power on January 1st of next year? And we take a probability every day. It doesn't change every day, but they can change whatever they want. And at the end of the time, we then sum up their score. If they were perfectly correct every time, they've got a 0. If they were dead wrong every time, actually they have a 2. So this is a scoring that says that if you were omniscient, you'd get 0 error. If you flip coins randomly every time, you get a 0.5. And if you're just pessimally, if you're so clever to be wrong every time, you get a 2. But we ask them every day, how is this doing? What's going to happen? What's going to happen? What's going to happen? Score them. Again, the details don't matter. Technically, any proper scoring rule will do, but this is a good one, widely used. So what do? We ran 4 successive years of tournaments funded by IARPA. This is the funding agency of the intelligence agencies who are interested in predicting geopolitical events. By our mandate, we're looking only at non-US questions, and questions were always formed of something. Here's examples. Which countries will officially announce they will join the Asian Infrastructure Investment Bank? And they were formed mostly in dichotomous, will this country join or not? Sometimes in multi-outcomes. I've asked when will Nicholas vacate the office of President of Venezuela, but in fact the question was by X date, what's the probability he will have vacated? Again, very precise questions. It turns out it's unbelievably hard to ask quite precise questions. We had political scientists working like lawyers here, trying to formulate exactly, not will they be reelected, but will they be in power, which is not the same in much of the world. What does it mean to be in power? What definition of that? What does it mean to, it's all well to say, will they launch a ground offensive? Again, that's slightly vague. What do I mean by a ground offensive? So very precisely defined questions. One of my collaborators, Phil Tetlock, likes to call clairvoyant questions. One that you could actually, if you knew it, would have a clear answer, yes or no. And that's, I think, a big piece and really hard. Cool, so here's typical tracking across the time is years. This is running from December 2011 into January 2012. And we have predictions, will Putin be inaugurated as president of Russia in 2012? Says your Putin question. And we can see great to be here. I went here undergraduate. There's always something magical about coming back to your undergrad institution, which is fun. 75 to 79. Embarrassing to say. Cool. And so we have a big team at Penn and across the country and the world of political scientists like Phil Tetlock, psychologists like Barb Mellers, data scientists like me, and lots of other people, on my PhD student Vila, who did this stuff at the end, trying to understand everything we can about how to make better forecasts, not so much quantitative statistical things, but predictions. How happy will I be with this person that I hire? Will this product launch work? And in our case, mostly geopolitical forecasts. What will happen in China or Russia or Africa? I'm going to try and do... That's an interesting question. We'll talk about what we can and what we can't do. So I'm going to do 3 things today. I'm going to try and cover them all. First of all, I want to make a big plea of why you should actually forecast and track outcomes, make falsifiable forecasts. That's my biggest message. It's really simple and really stupid and widely ignored across both the commercial and the industrial world. Secondly, I want to talk about what we've learned about how to select, train, and organize forecasters. We put together thousands of people making hundreds of forecasts. We have millions of forecasts collected. We've done a lot of experiments. I'm going to try and summarize them, in this case, in about 15 minutes. And then I'm going to sneak in a little tiny bit of statistics just for fun, but it won't be too much statistics. It's sort of the algorithmic side of putting these together, just because I can't resist, because I'm a computer scientist by training, only recently a psychologist.
So how many of your students go on to work for the CIA?
A couple. This is all funded by the IARPA, CIA. So yeah, we've done things. So research shows that people often make bad predictions. Psychology is full of people forgetting that predictions regress to the mean. People are really bad at taking lots of information and combining it. Computers are much better. Often intuitive feelings. You would interview someone, you really understand their great, how good they are, but that's an illusion mostly. Modern interviews are structured. How well do you do that? But we can do better. Now, it is the case that you're always going to be uncertain, knowing what was going to happen with Putin, knowing what's going to be the Arab Spring. There are lots of things you're going to get wrong. But we've gotten better at doing it. So I'm not going to promise doing well. All I want to say is if you look at enough people and think about it, you can learn to do a better job. And I'm going to try and be a little more precise about what that means. So historically, particularly in the intelligence agencies that fund this, but in most companies in general in life, forecasts are often of the form, there's a reasonable chance that, a good chance that Hitler will win. That's nice, but that's not the sort of forecast I want. What happens is when people say words like real possibility or distinct possibility, when you go back and ask them, on a scale of 0 chance to 100%, what did you mean? You get a frighteningly wide range of what does possibility or impossibility or sure thing mean? These are actually real data. If you look at this sort of in a more general thing across fields, what's the probability of election outcome? If you're a journalist, you know, it's too close to call. If you're a weather forecast, probability of rain, 50%. In Philadelphia, it's going to snow. Hey, might snow next week, going to snow. Investment, the probability of destroying the economy, 0 risk, high risk, no one could have foreseen, right? There's a lot of reasons to shade your predictions in terms of where they're going to go and to not give actual numbers that could be falsified. In particular, pundits, people who are professional at going on television and talking about these things, are really good at using words like could and might and possibly. There's a risk that recovery in the Eurozone could stall and demand might weaken so that deflation would be a real possibility. What does this tell you? Nothing. Nothing, nothing, nothing. Okay? But it's a nice equilibrium. The pundits don't have to admit that they're errors, and the policymakers aren't constrained by nasty facts. This is very comfy. And to their credit, the intelligence agencies are saying, can we change that? Can we actually change the culture and actually make falsifiable predictions? So, I probably don't need to remind people that lots of bad decisions happen. And these are quotes from major US policy makers. There's a serious possibility, there's a fair chance of success of the Bay of Pigs. First, what does a fair chance mean? A little unclear. Easy to evade pieces there. Statements of mass destruction. I don't say that the government should have known whether Iraq had or didn't have weapons of mass destruction, but we judge that Iraq has continuous probability 1. Is that really what you believe? I'm very skeptical about probability 1s. Yes, they do be their judge. And what's the chance of it being wrong? 0. They judge and has it. That's a nice weasel word, but again, it's not my kind of a forecast. If you can be vague, you can't learn. And one of the things I'm most interested in is in people getting better. How can we train our analysts, ourselves, to be better? To do that, you need to make quantitative predictions, not vague qualitative ones. Get feedback where you right or wrong, which means actually writing it down. Learn, you need to keep score. And that's really what we did. And I think probably in Silicon Valley, you don't need to argue this. There's a culture.